Hi, welcome back to my channel, and for today's video, we will be talking about invertible matrices for the systems of linear equations. Okay, so in this notion, there are actually many contexts at which we talk about the inverse of a matrix. Magkakaroon naman tayo ng inverse of a matrix even if it's not a square matrix. But in this case, we focus on an n by n matrix. So it's a square matrix. So over n. So an n by n matrix P is said to be left inverse. Naging left inverse siya of A if this one hold. So kung makikita mo, this is just the left of A. Kaya naging left inverse siya. And then right inverse naman siya kapag nasa right side siya ni A. In the event that if B is both left and right, and that means it holds in this case, then we say that B is a two-sided inverse of A. So in this case, a matrix A with a two-sided inverse is said to be invertible. Invertible siya or non-singular. So otherwise, singular siya. Okay, to illustrate on that, let's consider a matrix. So let's say our matrix here is 2, 1, 1, 1. And let us say we have another matrix M. In this case, our M here is 1, negative 1, negative 1, 2. Now, we will check if this guy is an inverse of A. Okay, let's check our product of A and M. So this is 2, 1, 1, 1, 1, negative 1, negative 1, 2. So if we multiply this, ang mangyayari magiging 2 minus 1, ito naman negative 2, plus 2. Okay. And then this one is 1 minus 1. And then I have here negative 1 plus 2. If you simplify that, you'll get 1, 0, 0, 1. So this is an identity matrix. So in this case, our M here is a right inverse of A. Now, we'll see if what is the result when we multiply M and A. So, ang mangyayari, this is 1, negative 1, negative 1, 2. Our A here is 2, 1, 1, 1. So, the product of this is 2 minus 1, 1 minus 1. I have minus 2 plus 2, and then minus 1 plus 2. If you simplify that, you'll get 1, 0, 0, 1. So this is also identity. So in this case, our M here is also a left inverse of A. In other words, M is a two-sided inverse. And because A has a two-sided inverse, which is the M, so our A here is singular, non-singular rather. If you have any question or clarification, please let me know. The fundamental reason why we're actually studying the non-singularity of a matrix, it's because, di ba, back in our previous discussion about the systems of linear equation, tapos yung mga coefficients, we can represent that into a matrix of coefficient. In fact, it acts like a matrix, although it's technically not as an original matrix, but it acts as a matrix. So ang mangyayari doon, the reason why we're studying on that is because we want to see the guarantee of the uniqueness of solution. With that, we will have to consider the fact of this claim. So if A has a left inverse B and a right inverse C, then this is the same. So nakita niyo kanina sa example, di ba, yung M natin, right inverse siya, tapos at the same time, left inverse siya. So this is just a reflection of this claim na the right and the left are equal, provided in the case that A here is an n by n matrix. Now, how can we be so sure if it is true? Okay, let's see the proof. If B is a left inverse of A, my implication is then Dahil left siya, by definition, di ba ganito siya? Also, if C is a right inverse of A, then ganito siya. This is by a definition lang naman, no? So our main business here is to show that at the end, B is just equal to C. Okay, our B, I can write that as B times the identity. Tama kasi whenever you have a matrix, if you multiply that by an identity, the result will always be the matrix itself. Now remember, our I here, as shown in this, is just AC. So I can have B AC. And we have already discussed before na associative yung multiplication ng matrix. So I have the fact that I can have this, tama? But we've shown already that our BA is I. So therefore, this is the same as IC. And what is IC? The product of an identity to any arbitrary matrix, the result is C. So this implies that B is equal to C. And so we have proven this claim. Okay. Okay, so we also have another claim here. Even that you have two matrices, the A and the B. So they're both square matrices over a certain field F. And if A is invertible daw, yung eto, the A inverse is also invertible. And this one, the inverse of the inverse is A itself. And number two, if both A and B are invertible, so the product is the same, and the inverse of the product is equal to the product of B inverse and A inverse. So I think I'm gonna prove only the one, and then I will leave it to you as exercise for number two. I'll just give you a hint for number two. But for number one kasi, just drop lang naman. If drop na lang 'to, kayo na bahala. If A is invertible, so the implication for that, then there exists B, tama, such that uh, our AB is BA equals I, tama? Kasi kapag invertible si A, ibig sabihin meron siyang two-sided inverse. Now, let's assume the two-sided inverse is the B. So that means it satisfies in this equation. Again, because this satisfies to having a product of I, I'm gonna define my B equals A inverse. Then, A inverse I have this as I, and I have A inverse equals I. Tama. So, paisipin mo parang ito yung A inverse, no? So, in this case, ang A here acts as an inverse. Tama? So, this guy here has an inverse. Okay. And then kayo na mag-formalize sa number 2. In fact, sinabi ko na nga kanina paano nag-prove ang 2 eh, based on the discussion on this part. So if you have any question or clarification, please let me know. Okay, another claim is an elementary matrix is invertible. Moreover, its inverse is also an elementary matrix of the same type. And we say here that a product of elementary matrices is invertible. Now, ito lang ang gusto nating patunayan. Okay, so now let's figure this out. Instead of showing the formal proof for this, uh, your E here, an elementary matrix, draft lang to, matrix, and then this corresponds to the elementary row operation. Row operation. And the elementary row operation, I denote that as E. So if E1 is the inverse operation ng A, and we let E1 equals E1 of I, then mangyayari, the product of this, I have this as E of E1, but again, your E1 is this, so I have E of E1 of I. This is the same as I. On a similar fashion, if I'm gonna have E1E, so this is the same as E1E, but this is E1 of E of I. Tama? And so this is the same as I. So what does it mean? This implies that your is invertible kasi meron siyang inverse na ang product na kapag gagamitin mo yung product niya with that certain inverse, the result is I. And so in this case, E1 is the inverse of A. Okay, let's try this for example. Paano natin mag-picture out yun? This one is an elementary matrix. This is invertible, and the inverse of this is in fact the same. So this is the same as 1, 0, 0, 1. So basically, I'm sorry, let me correct. Yeah, tama. 1, 0, and then 0, 1. Okay. So kung papansin mo, this is an elementary. So its inverse is also invertible at the same time. Okay, so let's have another theorem here. Ang sabi dito na if A is an n by n matrix, the following are equivalent. So, okay, ganito ang equivalency niya. A is invertible if and only if A is row equivalent to In, if and only if A is a product of elementary matrices. So, ibig sabihin, yung statement na pagiging invertible niya, nag-imply siya automatically and vice versa as A is row equivalent to I. And the statement A is row equivalent to In, it implies automatically and vice versa that it is a product of elementary matrices. Similarly, ito din, naka-if and only if siya. Because they are all equivalent. Let me illustrate to prove on that. So this is again not a formal proving. Kayo nang bahala mag-formalize. So let's say I have R which is in matrix which is row equivalent to A. So in this case, kasi naka-row equivalent to A siya and it's an RREF, this implies that I can write my R as, let's say, EK rather, up to the product of E2, E1, A. Yan. Now, if you notice, these are elementary matrices. Tama? So since EI is invertible, kasi elementary matrices naman sila for all I, implication is, dahil invertible siya, yung A natin, hinihintay natin magiging invertible if and only if I is also invertible. Tama? Kasi invertible na to eh. So, ibig sabihin, magiging invertible na lang siya na nakadepende siya dyan. But it's not really that depende because it's an if and only its if statement R also depends on A. So, in this case, since R is RREF, tama? So, R is invertible. Dahil naka-RREF siya, so R is invertible if and only if R is equal to I. This means that our A is invertible if and only if R is equal to I. And if R is equal to I, so ibig sabihin, these guys here na yung A mo is the product of this elementary matrices, which are the inverse of other elementary matrices. But we have proven already they are also invertible. So, overview lang siya to prove these statements. So, kayo nang bahala mag-formalize. Okay. Now, so now the fundamental question is, now, if you have a matrix, so how to determine if a matrix is invertible? So, meron kang matrix, you really have to identify if invertible ba siya, and if it's invertible, how to find its inverse. Okay, so let's say you have A, yung goal mo is how to find the A inverse. Yan. Okay, so here's the basic algorithm lang. First is that your A must, together with an identity matrix, must be written in augmented matrix. So naka-augment sila. So we put it, and then we convert that in a way in RREF. So let's say this augmented matrix naka-RREF siya. Let's say and the resulting RREF is CD. Yan. Then we have certain condition. Ang C, if C has zero row, so ibig sabihin, 'di ba, 'di ba ito yung mga ano mo, ito yung naka-matrix ganyan mo. So if may kunyari, makikita kang row dyan na puro zero, this means that A here as the original matrix is not invertible or it's singular. So otherwise, your C is equal to I. And in this case, D is the A inverse. So basically, kapag nag-succeed ka na wala siyang zero row sa C, so that means your C is actually the identity matrix. So automatically, D here is the inverse of A. So let's try this for example. So our A here is kunyari 2, 1, 1, 1, 1, 2, 1, 0, 2. Okay. This process, so parang ano, the inverse of A. So along the way, you would now jump into conclusion that A is invertible. Okay. So if you see your A here is a 3 by 3 matrix, so I can write that as A I3. Yan yung augmentation nila. So this is the same as 2, 1, 1, 1, 1, 2, 1, 0, 2. So this is 1, 0, 0, 0, 1, 0, 0, 0, 1. So kung nakikita nyo, this is your A, this is your I3. So paano nga yun mag-REF tayo? Gusto ko yung pinaka row 1, first column, I mean yung row 1 first column shall be 1. So in this case, pwede ko i-swap ano, ang row 2 at row 1. So I have R1 swap with R2. So the result part here is 1, 1, 0, 2, 1, 1, 1, 2, 2. So I have 0, 1, 0, 1, 0, 0, 0, 0, 1. Yan. Okay. Yung R2, I want this to convert this to 0. So I have, paano siya mag-0? So I will have to add this by negative R1. So negative 2R1 plus R2, that will be my new R2. So I have, syempre walang mababago sa row 1 at row 3. So let's just copy that one. Yan. Ang mababago is sa R2. But in this case, your R2 becomes 0, negative 1, 1, 1, negative 2, 0. So correct me if I'm wrong with my arithmetic, pero yan ang so far nakuha ko sa scratch ko. And ano pa, gusto ko ding mag-zero yung sa first column ng row 3. So what I'm gonna do is I will have to add R3 by the negative 1 of R1. So that is this one. So 1, 1, 0, walang nabago. 0, negative 1, 1, 1, negative 2, 0. So in this case na mangyayari is 0, 1, 2. And this 0, negative 1, 1. Okay. Also, in this case na, yung napapansin mo, yung R2 natin is negative yung mag-start, no? Negative 1. So I'm gonna multiply that by negative 1 to R2. That will be my new R2. So I have 1, 1, 0, 0, 1, 0, 0, 1, negative 1. Tama ba? This is negative 1, 2, 0, 0, 1, 2, 0, negative 1, 1. Yan. Okay. Now, next is my R1. Gusto ko ma-eliminate din to. So what I'm gonna do is, I'm gonna add R1 by negative R2. So that will be my new R1. So mangyayari, I have 1, 0, 0, and this is 1, negative 1, 0. Tama ba? And of course, walang mababago sa R2. So that's 0, 1, negative 1, negative 1, 2, 0, and then 0, 1, 2, 0, negative 1, 1. Yan. And then if I look into R3, kailangan ko pa itong mag-0 eh. Yan. So in this case, I have 1/3. No, no, no. Unahin ko muna to. But no 1/3? It's negative R2 plus R3. That will be my new R3. So 1, 0, 0, 1, negative 1, 0. So this is 0, 1, negative 1, negative 1, 2, 0. And in this case, I have 0, 0, 3. Correct me if I'm wrong. That's 1, negative 3, 1. Okay. And then, so ang mangyayari, okay na tayo, no? Ang problema na lang natin is, hindi. Kailangan ko pa 'tong magiging 1 siya kasi naka-3 yung start. So I'm gonna multiply that by 1/3. So that will be my new R3. So wala namang nabago sa row 1 at row 2. Yan. Yan. And then this is 0, 0, 1. That is, correct me if I'm wrong, that's 1/3, negative 1, 1/3. Yan. Okay, and last, I think dalawang step to, pero pwede ko lang isabay. Kasi, I want to make sure that my row 1, wait lang, parang may bago ako. I think may mali ako. It should be 1 pala. And, so kaya gusto ko siyang maging 0. Tama. So I'm gonna have row 1 minus row 3. The result is row 3. So in this case, this becomes 1, 0, 0, which is 2/3 baka mo. 2/3, and this one is 0. And this is 1 is negative 1/3. And then, yung R2 ko, sabay ko na lang, that is so R2 plus R3 goes to become R2. So this is 0, 0, 0 na to kasi nag-add tayo. This one is negative 2/3. Okay. And then this one is 1. And then this one is 1/3. And then also this one is 0, 0, 1. I have 1/3, negative 1, 1/3. So as you can see, kung titingnan mo yung nasa kaliwa dito sa augmented part, this is an identity matrix. So di ba from here, lumipat siya as pinakauna. So this one is our D. So this is now the inverse of A. So ito siya ang inverse of A. Okay, so another claim is, given that you have two matrices A and B, they are M by N matrix, so not necessarily square, then B is row equivalent to A if and only if this one, for some invertible P, which is an M by N. So, paano yan? In this case, guys, kasi this guy is M by N, this is M by N, this is M by N. So the resulting part is M by N, which is the B. So that means legit pala siya na operation. And in fact, because they are row equivalent, this one, so pwede mo siyang isulat as the product. One is the product of the other. Kasi di ba row equivalent, ibig sabihin parang may na-modify lang sa row, but wala talagang nangyaring changes. Ang changes lang, quote-unquote, na nakikita natin is either the row is multiplied by a scalar or it's a multiple of the other row and so on. So, dito tayo mag-focus instead. Now, let's say you have an A, B, and N by N matrix. The following are equivalent. Now, A is invertible, and then so it implies the homogeneous systems AX equals 0 has only the trivial solution x equals 0. And number three, the systems of equations, which is AX y equals y, has a solution for any y. Okay, so how do we prove that? So I will have to show you the draft of the proof. Now, let's focus on number two. As you can see, 2 here is equivalent already to the fact that A is row equivalent to IN. In fact, alam na natin to kasi na-discuss na to before, di ba? Okay, a homogeneous system. In this case, when A is invertible, so it has a trivial solution. So in this case here, 1 and 2 are equivalent. Okay, now let's focus on the fact that if A is convertible. So kung mangyayaring convertible si A, ibig sabihin the solution of AX equals Y, dahil invertible naman si A, that means you can simply multiply by A inverse. Tama? And so, in this case, this is X equals A inverse Y. Okay. Okay, conversely, your AX equals Y has a solution for each given Y. Yan. So here, let R be an RREF, and which is equivalent to it, to A. Yan. So in this case, we claim here, nakadrop lang to, R is equal to the identity. So when we say R is equal to the identity, this is equivalent to saying um, that we want to, this is just the same as to showing the last row of R is not zero. In fact, this is not identically zero. Yan. Okay, so we let our E be this one. 0, 0, and 0, 1. Yan. So if that's the case, so if the system Rx equals E can be solved for X. So the last row of R cannot be 0. Okay, in this case, we know that yung R is equal to PA for some invertible matrix P. Okay, okay. That is back on the previous theorem. Now, thus, your Rx is equal to E if and only if AX is equal to P inverse of A. We can do that because of the fact that kasi yung R mo is PA. And so if I'm gonna replace this by PA, so I have PAX. But P is invertible, so multiply ko yung invertible na yan dito. So maging I ito. So it's AX equals P inverse A. E. So the statement says that by 3, the latter system has a solution. So in this part, it's very now obvious that we have shown this. So if you have any question or clarification, please let me know. And that's all for this video. So thank you so much for watching. So if you have any questions or clarification, you can comment down there so we can discuss on these clarifications. And Of course, I would love to encourage you to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon regarding on discussions of mathematics as well as the research journey. Thank you and have a great day.